Hey Algebra 2 students, this is Miss Prater. I'm going to be out of the office and I wanted to record a lesson for you on 7.06. We're not going to go through the do now or any of that, but we will look at the announcements. This week you actually have 3 quizzes. Last week I think you only had 1, so it looks like we kind of doubled up this week. Monday, 706 day 2. 706 was a long module. We broke it up into 2 days, and the quiz was assigned for Monday. Tuesday 707, module 707 with a quiz. Wednesday and Thursday the 708 module is also fairly lengthy, so we decided to break that into 2 days, and the 708 quiz will be on Thursday, and then Friday is a catch-up day, and next week is Thanksgiving break. Yay! I hope you're excited about having a week off. I hope you find something fun to do. If you want to find something fun to do, if you want to visit your family, if you want to just hang out and do nothing, or if you're very behind on your schoolwork, you might want to take some days during Thanksgiving break and work on those, because when we come back, we have 1 week of school before we go to modified block and we start reviewing for the semester exam. Quarter 2 end dates are December the 9th for teacher graded assignments and December the 11th for computer graded assignments, and the end of the semester will be here before you know it. We're going to be looking at course of study number 21, solving special triangles and using the unit circle. I wanted to start off by reviewing special triangles. This is something that you did in algebra and geometry. You may not remember it, so I do want to talk about special right triangles. If you have a right triangle that has a 30-degree angle in it and a 60-degree angle in it, the side opposite of the 30-degree is considered the short leg, and the short leg times 2 in a 30-60 is always equal to the hypotenuse. And then the short leg times the square root of 3 is always equal to the long leg. So again, the side opposite of the 30 is considered the short leg. The side opposite of the 60 is considered the long leg. And then the side opposite of the right angle is always the hypotenuse. There's always that relationship in a 30, 60, 90 right triangle. Moving on to the 45, 45 and a 45, 45 right triangle. The 2 legs are always equal because their base angles are equal, and then the hypotenuse is always calculated by taking the leg and multiplying it by the square root of 2. So the legs are equal. The hypotenuse is a leg times the square root of 2. And the reason we kind of go back and refresh our memory about special right triangles is because they're built into the unit circle. So anytime you are dealing with the unit circle, if we were in brick and mortar, I would probably make you memorize everything that's on the unit circle, but because you're doing school virtually, you can definitely Google unit circle and you can use all the information that's on it. So back at the beginning of Unit 7, we talked about the degree measures, and so these are going to be on the inside of this particular unit circle, and then the radian measures will be the pi over 6, the pi over 4. So angles can be measured in either degrees or radians, and then we're adding to what we did in the earlier part of Unit 7. We're adding these ordered pairs that are on the outside. This is called a unit circle because if we look at one radius, so if we look at one radius, it is 1 unit long, and we know that because the ordered pair here is 1, 0. So 1 unit to the right, 1 unit up, 1 unit to the left, 1 unit down. That's why this is called a unit circle. And then we have ordered pairs, just like we were going, right 1, nowhere up and down. If we went right, square root of 2, up 1/2, we would get to the angle 30 degrees. If we went right, square root of 2 over 2, up square root of 2 over 2, that would get us at 45 degrees or pi over 4 radians, and so forth. So we're adding in these ordered pairs. In this gold box, it is important to know that anytime you're using a unit circle and they asked you for sign, it is the y value in the ordered pair. So quick reminder here, If you have an ordered pair, the x value comes first, the y value always comes second. So when they're asking you for the sine value, they're asking you for the y value. Cosine, they're asking, that's the x value. So anytime they ask for cosine at a particular angle, you're going to give them the x value of the ordered pair. And tangent will be a little bit harder, but when you're doing tangent, you're taking the y value from the x, from the y value from the ordered pair, and you're dividing it by the x value. So this is a little bit new. Unit circle is something that you've not done until you got to Algebra 2. Hopefully you'll use this reference guide for the unit circle, and you'll look at all the rules and the formulas that I have for you. Cosecant is the inverse of sine, so it's going to be 1 over y. Secant is the inverse of cosine, so it's going to be 1 over x. Cotangent is the inverse of tangent, so it's going to be x over y. In the first 4 examples, it says solve the following problem using the unit circle. Solve the following problems using the unit circle. So number 1 says sine, so that's the y value. Sine is the y value at 90 degrees. So we'll go to the unit circle, we'll find 90 degrees, and we'll look at the ordered pair. Since they're asking us for sine, we only want the y value, so the answer to this one is 1. Number 2 is asking us for cosine. When you're using this unit circle and they're asking you for cosine, they're asking you for the x value at pi over 4. So we'll find pi over 4, which is here, pi over 4 radians. And again, since they're asking us for cosine, we're only looking for the x value, and that would be square root of 2 over 2. Number 3 is asking us for sine, so again that's the y value at 5 pi over 4. So 5 pi over 4 radians is here. They're asking us for sine, which is the y value, so that would be negative square root of 2 over 2. Sine is y value, cosine is x value. In number 4, they're asking us for the cosine at the angle 135 degrees, so this time they're giving us the angle in degrees. Cosine is the x value. So we find 135 on the unit circle, and we only give them the x value, which would be negative square root of 2 over 2. So sine is y, cosine is x, tangent is a little bit harder because it's y over x, and we'll probably do a tangent in one of our example problems. The next 3 are a little bit harder than the first 4. The reason I chose number 5 is because 7 pi over 4, I don't know why, 5 is not any harder than 1 through 4. Alright, cosine is x, 7 pi over 4 is on the unit circle. So number 6, negative 30 is not on the unit circle, that's why that one's harder, and so same reason for number 7. But 5 is as equally difficult as the first 4. We're looking for only the x value, so we would only be getting this value here, and that would be square root of 2 over 2. Now, number 6 is a little bit harder. They're asking us for sine at negative 30, so sine is the y value. The problem with this example is that negative 30 is not on the unit circle, but positive 30 is, so let's use that. So if we rotate to this angle, that is positive 30. And remember, when we rotate clockwise, that is negative movement. So if we rotate 30 degrees in the opposite direction, this would be considered negative 30 degrees. It's the same as positive 330 degrees. We're looking for the y value, so we would only get the y value from the ordered pair, and that would be negative 1/2. Number 7, sine, so that means we're looking for the y value at negative 2 pi over 3. So again, negative angles are not going to be labeled on the unit circle. So let's go and find positive 2 pi over 3. So positive 2 pi over 3 is here. So that would be rotating 120 degrees counterclockwise. So if I rotate 120 degrees clockwise, that's going to put me at negative 2 pi over 3. So this would be 30, 45, 60, 90, 120. This would be 30, 45, 60, 90, 120, except we're going clockwise, which is negative movement, and we're looking for the y value only. So our answer is going to be negative square root of 3 over 2. So all of these values, we're using those special right triangles to get these values. You really don't have to do that. You don't have to do the math, but special right triangles 30, 60, and 45, 45 are actually used to get the x and y values on the unit circle. You can just use this unit circle as a reference and just know that sine is y values, cosine is x values, tangent is y over x. Angles are getting a little bit larger here. So on example 8, we're looking for 600 degrees. So we've got to think about if we go all the way around, that's 360. And we've got to get to 600. So if we go, let me grab my calculator. If we do 360 plus 90, my brain tends to go by 90s. So if we go around again, that gets me at 450. If we add 90 to that, that gets me to 540, which would be here. And if we add 90 to that, that gets me at 630. So if I go here, all the way around and around again, that gets me at 630. So I'm just trying to get to 600. This is 540. So we would have to add 60. So this is 60 degrees here, and then this would be 600. Another way to look at that is you can take this 240 and you can add one whole revolution, which would be 360, and that would give us 600 degrees. So we're talking about this angle right here, and we're looking for cosine, which is the x value. So that means we only want the x value from the ordered pair, and that's negative 1/2. And there's more than one way to find out that this is 600 degrees. But you could think about, each one of these, if you add 360 to them, that just means you've gone around and around again to get to that angle. All right, 9 pi over 2. A couple different ways you can do this. I tend to kind of focus on the fact that, this is 9 pi over 2's. So this would be 9 90s. Again, all kinds of ways to think about this. But if we think about 9 pi over 2's, we could just count it. So this would be 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, and 9 pi over 2. So think about that again. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2. We're looking for sine, which is the y value. So that would be this value here. So that would be 1. Finally, we get a tangent. So tangent, we're going to have to divide y over x. The y value divided by the x value, and we do have to find 7 pi. So my brain says, well, to get to 7 pi, we could go around once. And if we go all the way around once, that's 2 pi. And if we go around again, go around once, that's 2 pi. We go around again, that's 4 pi. We go around again, that's 6 pi. And then we got to go one more pi, which would be here, because this is pi, and that would put me at 7 pi. So again, 1 revolution is 2 pi radians, 2 revolutions is 4 pi radians, 3 revolutions is 6 pi radians, and then you go half a circle, which is pi radians. That puts me at 7 pi, and we're doing the y value. So the y value divided by the x value. So that's going to be 0 divided by -1, which will give me a final answer of 0. So tangent's just a little bit harder because you've got to take the y value of the ordered pair and divide it by the x. Alright, that's the lesson on 7.06. Hopefully you found that helpful, and you can go through module 706 and be on your way. If you have any questions, let me know. I'm just out Monday, out of the office Monday, and I will be back on Tuesday, and y'all have a great day. Thanks.